Hey friends, welcome to RARK. This is second tutorial in the series of Learn Graphs from Scratch for IIT JEE. And today we are going to be discussing about modulus function. So let's start. Modulus function can also be stated as absolute value function. Some people use absolute value function and some use modulus function. Both are same. So let's first define it. What is modulus function? According to definitions, modulus function is written like this, and we read it like mod of x. So it is nothing but two parallel lines, and between them is our variable x. So modulus function is stated like y is mod of x if y is mod of x, which is equal to x if x is greater than equal to 0, or equal to minus x if x is less than 0. It is basically taking the absolute value, means the distance of a number from the 0 position. So let me illustrate you. Suppose this is a number line where these are positive axes and these are negative axes, and this is 0. From where we are going to calculate the distance of numbers. This is 1, this is 2, this is 3, this is 4, this is 5. Here minus 1, minus 2, minus 3, minus 4, minus 5. So if I'm going to say modulus of minus 5, it means distance of minus 5 from 0, and undoubtedly it is only 5 units. So I'm gonna say mod of minus 5 is 5. Also, if I'm going to calculate mod of 5 plus sign, it is distance of this from origin or 0 axis, and this is also 5 units. So basically modulus function gives the absolute value of a number. So mod of minus 5 is also 5, and mod of plus 5 is also 5. If I'm going to say mod of minus 3, it is just 3. It is actually a number without any sign, positive or negative. No sign is indicated in absolute value function. It is opposite of signal function. We'll talk about that later on. So let's move forward. Now we are going to discuss some properties of modulus function. Properties. The first property of modulus function is x mod, I should say, y is equal to mod x, which is in turn equal to, I should just use it like this, root of x square. This can be stated as alternate definition for modulus function. This is alternate definition to the modulus function or absolute value function, because this sign that you are seeing, this under root sign, restricts our number to be just with positive sign. Actually, modulus function always gives positive output. Whatever the number is, be it minus 2083, modulus function will always give plus 2083. It is only the number with the positive sign. So it is just the distance of 2083 minus 2083 from 0. So now move on to next property. Is second property is modulus of x is greater than equal to 0, that is non-negativity. So modulus function is always positive, as I stated some seconds ago. So let's move on to another property, and that is mod of x is equal to 0 implies that, this is implication sign, This implies that x is equal to 0. This property means positive definiteness. So let's move on to fourth property. X into y, and taking mod of the whole, is equal to mod of x into mod of y. This is multiplicativeness. Yes, property of a modulus function. So if we are going to take modulus of -3 into 4, it's going to yield modulus of 3 into modulus of 4. Because we are going to calculate, it becomes -12 mod, which is nothing but 12. And if we are going for RHS, we will get 3 from this and 4 from this. Multiplication sign between them, it yields 12. So we got the same result. So this property is correct actually. Now we move on to fifth property. Mod of x plus y is always less than equal to mod of x plus mod of y. This is called subadditivity. It means the modulus of summation of two numbers is always less than or at max equals to modulus of first number plus modulus of second number. Let's try it with some example, like modulus of -6 plus 1 is equal to -5 modulus, and it gives 5. On RHS it gives modulus of -6 plus modulus of 1. It gives 6 plus 1. It gives 7. So we can see that 5 is less than equal to 7. And if we are thinking about the max case at which this is equal to, let me show you. That case is when both the numbers are positive. Like, let's not take 6 again, let's take 10 and let's take 2. Modulus of 2. Here we have modulus of 10 plus modulus of 2. We got modulus of 12. This gives 12. Here we have 10 plus we have 2. This gives 12. So here in this case it is equal to. Just try out with some more examples by yourself and you will find that this property is very, very correct, and this is very, very helpful in exam, that modulus of two numbers is modulus of sum of two numbers is less than or equal to modulus of first number plus modulus of second number. Let's move on to sixth property. Sixth property is modulus of a number. Let's take like this, and let's take again modulus is equal to the first modulus of a number. Why a number? This is called idempotence. Which says absolute value of a absolute value is absolute value of the number itself. Which means if you are going to calculate double modulus of a number, it is equal to the first modulus of the number. So there is nothing new if we calculate double modulus. Double modulus, triple modulus is also same. So if we are taking mod of x, again I take modulus, and if again I take modulus, it's gonna be just first mod of x. And if I again take modulus, it's still gonna be first mod of x. This is a property, and you can check it out by yourself, because modulus of positive number is a positive number, while modulus of negative number is also same number but with positive sign. So if we are calculating modulus of -4, it gives us number 4 with the positive sign, and if I calculate again modulus, it becomes a modulus of positive number, and which is again the same number, positive number. So it becomes, if I again take the modulus of +4, it gives +4. If I again take the modulus of this number, believe me, it's again +4. So if I again take the modulus, it's still +4. So you got the idea why modulus of any time, n times if you take, it's still the first modulus of the number. So this property is not quite useful, but I should tell you, that's why. Now comes the seventh property, modulus of negative of x is equal to modulus of x. Well, this property is called evenness. It is reflection of symmetry in graph. I will tell you the graph later on, but this property is minus says that negative of a number, and if we take the modulus of that, is equal to the same number without the negative sign and modulus, because no matter what sign it is inside, the output will always be a positive number. So if we take minus here, it's still gonna be getting plus. If you take plus here, it's still gonna be getting plus. So let me show you with an example. Minus of 3 modulus is equal to 3, and plus 3 modulus is also equal to 3. So it doesn't matter which sign it is inside. And if we take modulus of -2083, it becomes equal to modulus of 2083, which is equal to 2083. So actually modulus is only the distance between the number and 0th point. So that's why this property is true. The next property is its property, modulus of x minus y is equal to 0 implies that x is equal to y. This is called identity of indiscernibles. This is equivalent to positive definiteness, I should say. This property says that if the difference between two numbers and modulus is taken on the whole is 0, that means the two numbers are same. Let me show you with the example. If we take modulus of 3 minus 4, this cannot be equal to 0. Only way it can be equal to 0 if the distance here is 0. So if we are going to take a number line, if we are taking the distance, it will be 0 only if the input is 0. Distance is this one, is the distance. So input is 0 means x minus y is 0, which means x is equal to y. That's why this property is true. So this is kind of less helpful also. This is very less helpful property. Next property is ninth property. It says modulus of x minus y is less than equal to x minus z plus modulus of z minus y. This is called triangle inequality. This is equivalent to subadditivity. So in this property, if we look at, let's take three numbers x, y, z, be 1, to 10, say. So x minus y is 1 minus 2, mod is 1. And if we take RHS side, it becomes 1 minus 10 mod plus mod of 10 minus 2. It gives me 9, and this gives me 8. It becomes 17. As we can see, 1 is less than equal to 17. This property holds true for this case, and you have to try it for a lot more examples to check it out for yourself. I'm not gonna show you the proof of this property, but this property is very useful in trigonometry and some other like applications of trigonometry. There will be a chapter in your class 12th. So next property is 10th property, which is x divided by y, and if we take modulus of the whole is equal to modulus of x divided by modulus of y, if given that y is not equal to 0. This is called triangle, sorry, it's called equivalent to multiplicativeness. This is division property. Equivalent to multiplicativeness. This property is equivalent to multiplicative property, as I showed you, that modulus of xy is equal to modulus of x into modulus of y, and this is same but in division. Modulus of x by y is equal to modulus of x divided by modulus of y. So you can use it anytime, anywhere you want, because it is like modulus of minus 3 by 4 is equal to modulus of 3 by 4 modulus. So it gives me minus, and this gives me 0.75. Here it is 3 by 4 and this is 0.75. So this is correct. You can check it out yourself. Now we have our 11th property, which is mod of x minus y is greater than equal to mod of x minus mod of y. And if we take the mod again, I'm not gonna show you the proof, but you gotta use it as it is, and it is called reverse triangle inequality. This is equivalent to subadditivity. Now here are some very basic and quite evident properties also. Like first one is mod of x if less than equal to y, which implies that minus 4, like this I should write down, and if mod of x is greater than equal to y, which implies that or like this. So it's also an observed property, and it is very useful in exams. You should keep it in mind, or you should just write out yourself and you will find this property. Now let's move on to some complex number use of modulus function. A complex number, it can be denoted by z, and it is equal to real part plus iota and imaginary part, like this. It is like x plus iota y. So if we are going to, it's also written like this, r e to the power iota theta in polar form, like this. So if we are going to draw the graph of complex number, this is real part and this is imaginary part. It's like y, this is minus y, this is real part, and a complex number is denoted like this, z equal to x plus iota y, and here comes z conjugate. This is complex conjugate of the number, and this is x minus iota y, and this is phi, this is phi, this is r. So this is also r. This is a basic drawing of a graph of a complex number. These are same actually. I'm not drawn to the scale, but these are same. So modulus of z is nothing but distance of that peak point from origin. This is origin and this is r is the modulus, so it is x square plus y square. So modulus z in polar form, if we take the graph and find out, it is nothing but r. So here are two properties of modulus. First is z is equal to modulus of z is equal to modulus of the number into its complex conjugate. And second property is very important, and you should keep it in mind, that modulus of z is not equal to root of square of a modulus. This is the only property which is different from the properties that I mentioned earlier in case of real numbers. Only real numbers actually, yeah, real numbers only. So positive numbers, yeah, as I mentioned, all the properties earlier are also valid on this complex number except the first property, that was that mod of x is equal to root of x square. This is not valid in case of complex number, except that all those properties, that multiplicativeness, subadditivity, idempotence and evenness, all those indiscernibles, all those properties are valid on complex number also. Now let me tell you about signum function. Signum function. In signum function can also be stated as like this. If I take any number and signum function is denoted like this, signum of any number is either 1 if x is greater than equal to 0, is equal to -1 if x is less than 0. So it actually gives the sign of the number. I'm not sure about this, is it equal to or not, but let's take it for now. So a signum function actually gives only the plus or minus sign, while the mod function only gives the absolute value. So these are kind of opposite in nature, and we can say like modulus of x is equal to x times signum of x. Signum function is also said sine function. Some people use it like sine function, and I prefer saying signum function. So this can be written like this: modulus of x into signum of x gives the x itself. Signum function can now be taken like this also. Signum function of x is modulus of x upon divided by x. So this only gives you the sign of the function where stated that x not equal to 0. So signum function is basically valid for all the numbers except 0. So in my definition that I stated earlier, let me take it like this: signum function of x is minus plus 1 if x greater than 0 and minus 1 if x less than 0 for all the values except 0. So now I have two more important properties of modulus function, that are that derivative of a modulus function with respect to x is equal to x upon modulus function of x is equal to nothing but -1 if x is less than 0 plus 1 if x is greater than 0, and integral property, that is modulus function of x is equal to x into mod of x by 2. I'm not going to show you the proof of these, you can find it out yourself. These are very basic properties of mod function, but these are used more than the other properties that I mentioned earlier, so you should keep it in mind also. So now I'm gonna just show you the graph of a modulus function. Y is equal to mod x. The graph is drawn like this. A straight line here and a straight line here. This is why I will tell you, because y is mod x is nothing but equal to x if x is greater than equal to 0 and minus x if x less than 0. So if x is greater than equal to 0, the graph goes equal to y is equal to x. And if x is less than equal to 0, graph goes like y equal to minus x. This is the graph of y is equal to minus x. The graph goes like this. This is origin. These are plus y, minus y, plus x. So these are minus x axis. This is a graph of a modulus function. So these are lines, so I should draw it like this. So we got this, the graph of modulus function. You waited long to see this, and now I'm going to show you how to make modulus of any function. If the function was like this, let's say it goes like this. This is the function y is equal to f of x. So if I have to make y is equal to mod of f of x, you have to apply your basic rules, basic mathematics, and you're gonna get down to this graph, and it will be like the negative part of graph will become positive part in symmetry. This part becomes this part. You're gonna rub this one, and then rub this one. If this side the graph was like this, gone, so it will become like this when taken mode, and it will go like this, and you're gonna rub this part. So the graph of any generalized function, if you take the modulus, all those parts which were negative earlier becomes positive. These points are indifferentiable, so you should keep that also in mind. So if I draw the modulus of sin x, earlier sin x was like this, and if I take modulus of sin x, it will become like this. Equal height is taken like this, and I'm going to remove this, and same goes like this. My graph is not to scale, but you could see that the basic idea that I'm trying to convey, and the graph becomes like this. So it is indifferentiable at all these points, but you got the idea. If you are going to draw the modulus of cos x, it's gonna be like this. The cos x was like this, and here also like this. So if we take the modulus, it becomes positive, we gotta rub this part, it becomes positive here, it becomes positive here. So modulus of cos x is this graph with all these values equal to 1, and these are pi by 2 separated numbers on positive x-axis. These are actually radians, and this is the output of y is equal to mod of cos x. So that's fine. That's all for this video. Thank you guys for watching. Please do subscribe to my YouTube channel. Thank you.